As you all know, my name is Jeff Crocker. I'm a supervising river ecologist for the Vermont Department of Environmental Conservation in the stream flow protection section. I'll go and list I have participants. John Groveman.
Yeah, thanks, Jeff. I'm John Groveman. I'm the Policy and Water Program Director for the Vermont Natural Resources Council.
Thank you. Evan? Oh, you're on mute.
Sorry about that. Evan Fitzgerald, hydrologist and geomorphologist with Fitzgerald Environmental.
Jason?
Yeah, Jason Shaddy here. I'm the general manager at the Burlington Country Club and representing the Vermont Golf Course Superintendents Association.
Thank you, Jason. That's Jeff Nelson.
Jeff Nelson, principal with VHB, here representing the Ski Areas Association and having worked very extensively on a lot of different regulatory matters involving water over many years.
Thank you, Jeff. Brian?
Yes, hi. Good morning. Ryan Patch with the Vermont Agency of Agriculture, Food and Markets. I'm the Deputy Director of the Water Quality Division. Thanks.
And Sam? Oh, you're on mute, Sam.
How's that?
We can hear you now. Yep.
You can? Okay. My name is Sam Markowski. I'm part owner of a construction company in Florence, Vermont called Markowski Excavating, but I'm here because of our agricultural activities, working with Ryan Patch with the Agency of Agriculture on this matter.
Okay, thank you. And David was having some trouble. He just emailed me, so I sent him a new link. Hopefully he'll be able to get in. But I want to move on to our first speaker, Dr. Leslie Ann Dupini-Giroux, with the Vermont State climatologist and professor with Department of Geology at UVM, will give a presentation on precipitation patterns and how they may change in Vermont with climate change. So, ready when you are.
Thanks a lot, Jeff. Thanks for the invitation. Thanks to Matt Chapman as well for the invitation to be here for a few minutes. What I thought I would do is to give a sort of high-level overview, take a deep dive into some of the water resource issues that are facing the state, have faced the state, and will be facing the state. And then I will sort of end up with showing you some resources online that you may want to sort of delve deeper into, because sort of highlighting the ability to get water resource information pretty much on a zip code level. So I'm not sure all of the tasks that are going on as part of this particular working group, but I thought it might be helpful to at least to give you the fire hose so that you can take whatever from the fire hose you may need to. So let me go ahead and try and share my entire screen here. And let me know if you're seeing that. Okay. Was that a thumbs up?
Thumbs up. Looks great.
Okay, perfect. Alrighty. So Leslie Ann Dupini-Giroux, professor in Department of Geography at UVM, Vermont State climatologist, and a couple other hats that I'm going to bring to bear as we sort of step through and look at some of these pieces in here. So for the purposes of this particular group, we're looking at the water side of climate as a system. So we're looking at when the precipitation falls, what happens is it infiltrates surface water storage, groundwater storage, and all of those various pieces from a management perspective, so that if anything changes in our climate, and we're looking at changes in either precipitation, which then cause changes in soil moisture, changes in where that water is being stored, looking at how those groundwater pieces sort of come together for us. Those are some of the things that I want us to kind of keep in mind from an overarching perspective before we do that deeper dive. So in looking at climate change and looking at some of the things that we are going to be talking about, whether it's precipitation, whether it's land use, whether it's temperature changes, I know we're probably not going to get into fossil fuels and greenhouse gases in this particular group, but I just wanted to kind of lay the groundwork for the ways in which we can be thinking about climate change, the water use changes, the changes in terms of the impacts, who has water, who doesn't have water. I heard somebody say that they were representing the ski industry. Another person was representing the golf industry. And so how do we use water? How do we think about the ways in which the availability of water is changing, has changed, and will continue to change as climate changes. So I like to kind of show this slide to ground us in terms of where we're looking. And one of the things that's really, really important for us from a water resource perspective is looking at the trends. So the trends towards either increased precipitation, increased amounts of precipitation, but more and more this understanding of increase in the variations, the back and forth between going floods to droughts, sometimes in the same year, and then what that means for us in terms of human systems. And so I'm going to come back to this diagram in a little bit because it sort of sets up for us a lot of the dynamic, a lot of the tensions that are going to be important in this particular working group. So cutting to the chase, what does climate change look like for us in the state? Well, one of the ways that we can talk about climate change is the minimum temperatures, the nighttime temperatures are actually getting warmer and warmer. And that's one way that we know that climate is changing. The other way that we can look at climate change is how much rainfall, how much moisture, how much snowfall are we getting in the various seasons and whether that's also changing. So we've got winter, up in this upper left here, we've got spring, we've got summer, and we've got fall. And you see that we're getting more precipitation in all of these various seasons, with the clearest trend being, of course, in your summertime conditions. And then we're also seeing this sort of variation in both the springtime conditions as well as in your wintertime conditions. So what does that mean for us as a state? What does it mean to have these moisture extremes going back and forth? And so when we think about climate change, and I'm going to just focus on this lower diagram here for a sec, what we're seeing is that there's a shift in the precipitation distribution away from light or small amounts of precipitation, shifting more towards heavier precipitation, so larger amounts falling more frequently. And what that is important for is that it has a particular implication for our communities, but also for our water use, also for our infrastructure. And so some of these might look like they have been from Tropical Storm Irene, but they're not. There are other examples from across the US, but it just sort of brings us to the point of sort of appreciating what having more heavy precipitation looks like. And so again, this could have been from the southern part of the state during Irene. And this is of course, a lot of the flooding that took place in New York in Tropical Storm Sandy. So why do we need to sort of look at increases in precipitation across the state? And part of it has to do with the fact that our roads and our rivers are pretty much close to each other. They're juxtaposed because of the fact that a lot of our valleys are V-shaped, and so the rivers and the roads are literally next to each other, and that sets up a particular dynamic for having repeat flooding occurrences in certain parts of the state. So along Route 100, for example, the J area is another place that we have a lot of repeat occurrences of flooding, and that allows us to think about where are some of the touch points, where are some of those places that are particularly vulnerable to increase amounts of rainfall, including the town of Waterbury, which was isolated because of the pinching off here and here during Tropical Storm Irene. And so Jonathan Croft, VTrans, put together this map after Irene that shows you the roadways, the highways that were affected during Irene. Those are those colored lines here, the yellows, the greens, and the reds. And those are superimposed on a flood damage map from 1927, which was, of course, the flood of record up until Irene for the southern part of the state. And so you see that a lot of those are sort of overlapping on each other, and that gives us a sort of heads up as to where some of those touch points are, where some of those critical vulnerabilities are from an infrastructure perspective. So when we think about infrastructure, when we think about increase in precipitation, one of the sort of increase in knowledge that we can look at to help us with our planning is this NOAA Atlas 14. And what NOAA Atlas 14 allows us to do is to bring in the increases in precipitation that we've been seeing so that we can do different types of probability analyses using the 1 in 100 year probability, for example, or the 1 in 10 year at various time frames, so the daily or the sub-daily. And so what you're seeing on here is this NOAA Atlas 14, and it allows us to really drill down to specific parts of the state and see where those very, very high amounts of precipitation observed so that we can bring those into our planning models. And this is important because if we look at the values that were being used up until the year 2014, the yellow lines are the best that were available at the time, and they go back to the 1940s. And so you see right off the bat that using the most up-to-date information is going to behoove us because we can actually plan better at a better scale. So we're able to sort of drill into the micro scale features like the Green Mountains and the Taconics to really get a representation of where that heavy precipitation is forecast to be falling. So if we switch gears for just a little bit, another resource that I wanted to sort of offer you is the National Climate Assessment. And I was fortunate to lead the Northeast chapter of that particular assessment. And as part of that, each state has its own state climate summary. So here is the URL for the state climate summaries. I'm going to show you that when we step back out into PowerPoint in a sec. But the beauty of National Climate Assessment is not only does it look at past events, but it also brings in projected events in terms of extreme precipitation. So the update to this, you see it stops in 2014. The update to this is actually in the works right now as we speak. And so as it comes online in a few months' time, this is going to be another resource for us to be able to see where those extreme events are happening and the understanding of what those values actually are. So National Climate Assessment, particularly the state climate summaries, is an important piece for us in here. And as part of that, we're able to see where we're seeing things like changes in the timing of spring snowmelt and runoff, for example. And we're seeing that it's coming earlier across the North Country in here. And the way to read this diagram is the larger the triangle, the earlier it is, and the redder the triangle, the earlier it is. And so we're seeing, anywhere between 5 and 10 days earlier in terms of that spring snowmelt that we're looking at across this state here. If I drill a little bit deeper, related to that increase in snowmelt is it because we're getting more precipitation, especially in the summertime? And so these diagrams here, one on the left is precipitation, the one on the right is storm flow. And again, because the triangles show you the percentage increase, you're seeing increases in precipitation, again, across all of Vermont, and increases in the storm flow across all of the state as well. And these values are at least 50% increase in the storm flow and at least 20 to 50% in your precipitation. So we're seeing larger amounts of rainfall, both in the springtime from a stream flow perspective, but also from increases in your summer. So let's come back a little bit and look at this variation going from one extreme to the next, which is what this piece is in here. And one of the things that's sort of characteristic of the state is to be able to see those fluctuations, those variations from excessive precipitation to excessive deficits all in the same year. And so I've sort of selected a couple years to highlight that for you. So 1909 was when we had some of the driest times on record. 1927 was another time when we were dry, and then when we had that precipitation come in that led to the 1927 floods, we saw that going from drought to floods in literally 2 or 3 days. And then 2011 was unique in that we were pretty dry throughout the spring, and then we had the May rain on snow, excessive precipitation, high temperatures, and so we had some floods of record being set here for Lake Champlain, but also in the case of Tropical Storm Irene later on in the year. So when we have these deficits, we see it in not just the reservoirs, not just the ponds, not just your streams, we also see it in Lake Champlain. And so going back to 2016, looking at, this is St. Albans Bay, and looking at the extent of the dry conditions, so the decrease, that deficit in how far out the lake had actually receded because of the ongoing dry conditions that had been in place. So you're probably asking right now, how can we be in a drought if it's projected to be getting wetter? And so we're in a drought right now. We have been in a drought since at least June of last year. And so this is the heads up, the update that came out last Friday with looking at where we are in terms of our drought and looking at the fact that we're still in moderate drought conditions across parts of the North Country here. And what you're looking at on the right-hand side is the U.S. Drought Monitor, which gives you what the current conditions are on a week-to-week basis. So we're still in drought right now. And I had given a talk like this about a month ago, so back in April, and you can see that the drought about a month ago was even more extensive. So the entire state was in drought, and it was even more severe in looking at drought. So we're trying to see how this wetting and drying can occur at the same time, and why is it important to us from a water resource perspective. So this is the current map for the state. I gave you a slightly blow up version of this, and you can see a lot of the across the kingdom in here, getting towards the middle parts of the Connecticut Valley. Most of the rest of the state is in some form of drought itself, and we can look at the impacts and why is it critically important to know where we are in where that drought is playing out, not just from a moisture perspective, but also from the potential for wildfires, and also the potential for water resources declining over time. So we've had a fair bit of precipitation over the last month. So this is from April to this Saturday. So we've had some precipitation. It's been beneficial. We've been over 100% of average, which is great. And that has been able to produce a little bit of a dent, excuse me, in the drought that we're observing. But if we only look at a month, we get one picture. If we look at 6 months, we can see that we were really not doing that well, particularly across the kingdom and down into the Connecticut Valley in here, where we only got between 25 to 50, in some cases, less than that amount of average rainfall or precipitation across the state. So that's a 6-month time frame. If we go back for a full year, so May the 16th, 2020 up until now, we can see that the entire state has been below average conditions in terms of the precipitation that we got. So if we've been dry for so long, we're going to see it in our water supplies. We're going to see it in our groundwater. And so these are some of the wells that report across the state. And you'll notice that most of the wells on the eastern side of the state are in that below normal range. And the wells on the western side of the state that have gotten a little bit more precipitation are in the normal category in here. And this is, again, for yesterday. So as of yesterday, this is what our wells are recording. If we go back a month, we'll notice that when we were in that severe condition, and so the wells were either much below normal, so less than about 10%, and again, only on the western side were we seeing average conditions or normal conditions in terms of our groundwater. So it takes a while for the groundwater to be depleted. It's going to take a while for the groundwater to come back out. So about a month ago, maybe 2 months ago now, the USGS put out a report, and I'd be happy to send you this link or pop this link into the chat once we're all done here, talking about the drought across all of New England. And why that was critically important was we saw a lot of 30-year brand new low values across a lot of the state in here. And so that tells us, again, the extent, the severity of our dry conditions, and also points to why we need to be keeping our finger on the pulse in terms of not just excess moisture, but also dry conditions as well. And part of that is because it affects different sectors of our economy differently. So again, as of yesterday, the sectors that they were looking at, so we're looking at the yellows here, are reservoirs. So we've got some reservoirs that are in a dry condition. So most of that sort of central and northern part of the state, we're keeping our eye on our reservoirs. If I show you what it looked like a month ago, it was the ski resorts that were in those dry conditions, and sort of keeping our eye on the lack of snowfall and the way in which water withdrawals from our streams could have been impacted. So again, sector dependent, depending on the timing of a lot of this. So it's not just the rain or the snow that falls, it's also how dry the atmosphere is. Because if the atmosphere is really dry, it's going to sort of promote a lot of uptake from our waterways, from our vegetation if leaf out has occurred. And so as of last week, we're in the plus side, which is great. So we're on the wet side. But again, if I go back a month, we were really, really dry. And there were a lot of sort of wildfire alerts going out because the air was so dry. And again, that was sort of creating a lot of demand going from the soils and the water bodies up into the air itself. So drought is something that occurs in every climate, no matter how humid you are. And here are some of the sort of maybe 20, 21 year pattern of droughts across the state. And you're probably thinking, okay, so we're in a drought right now. And, we've had some other times that we've had droughts before. And if I go a little bit further back, so maybe back to 1895, you'll see a couple things going on here. So here are the recent droughts that we're looking at here. We can look at the fact that we had really severe droughts back through time. And the second thing that you're looking at here is, yes, we have droughts, and here is that trend towards more precipitation. So we're seeing droughts at the same time as we're seeing that trend towards increased precipitation. So that's one of the reasons why I say we need to keep our eye on both sides of that moisture coin, if you will. So here is something I wanted to introduce at this particular point, because I only learned about this about 2 or 3 months ago. So I'm teaching natural hazards right now at UVM. And this is a brand new type of drought that only got crystallized about 2 or 3 years ago. And so I'm introducing it so that everybody is on the same page with understanding this new way of looking at moisture extremes. And it's called ecological drought because it allows us to look at adaptive capacity, ecosystem services, ecosystem variations, and what we do as human beings in terms of water use, water extraction, and how that interfaces with how much moisture we're getting and what our streams, lakes, ponds, and groundwater supplies are doing. So ecological drought brings together human use with the actual amount of water that's in the landscape itself. And so I heard there were a couple of folks from DEC, water quality. So looking at water degradation, looking at fish kills, looking at how much water we have in the various parts of our water system is critically important. Bringing that in terms of do we have enough water for recreational use? Do we have a lot of blue-green algae to think about in a particular year? How much sediment runoff are we looking at here? And so this notion of all of these pieces of water quality, water quantity, both from an extreme but also from a deficit, critically important here. So here's what ecological drought has us think about. What are some of those land use patterns? What are some of those resource management challenges that we're working towards? What is the adaptive capacity from an ecosystem services perspective? And so in looking at this particular way of the entire landscape, I just wanted to offer that as an additional lens for us to look at because of this human, land, and water use all in the same place. And so the way that ecological drought plays out is to understand this notion of ecologically available water. So how do we think about the precipitation? Like I said, whether it's water or snowfall, how is that getting into not just the upper parts where the soil moisture is, not just the lower parts where the aquifers are, but then the human extraction piece in here. We're using it for some purpose. And how does all of this kind of fit together so that we can put our fingers on how much is available, how much is being used in various sectors, and then what does that mean for like downstream impacts and upstream impacts? Okay, who's using the water and how are we sharing some of those rights? So ecological drought is important to get a pulse on, because if it goes on for too long, what can happen is that the actual landscape can actually change. So if ecological drought goes on for several years and there's not enough ecologically available water, you can actually start to see shifts in biomes, shifts in water use as a result. And so then it becomes transformational drought. So I just wanted to offer that as an additional lens as we're thinking about all of those water use pieces that we're going to be looking at. So to transition into some of those websites that I said we would get into, Climate Explorer is one of them that allows you to pretty much drill down to the zip code level to look at not just past changes, but also projected changes out into the future that I will show you. And it also allows you to do different thresholds. So you may be interested in saying, what would happen if we had like X number of days over 2 inches of rain or 3 inches of rain? So I wanted to sort of offer that to you so that you can actually use that in maybe some of the planning that is taking place as part of this working group in here. So all of these to say, we're looking at all this from a systems perspective. There are a lot of these moving pieces where we need to keep our eye on different time scales. So not just a week, not just a month, not just a year, but longer than that. And then see what are those touch points in terms of the aspects of the human environment, the built environment, the natural environment, and how all of these come together to then influence the vulnerability of us as human beings, but also of our system as well. So with that, let me leave my email address here. This is my state email address. If you would like to reach out to me for either parts of this websites or so forth, I'd be happy to hear from you. And now what I'll do is actually sort of transition into the websites that I wanted to just demo for you for a sec. So the first one, thanks for this amazing resource. I hadn't seen it before, so I'm going to be really excited to delve into that and look at it a little bit further. So the first one I wanted to just highlight really quickly is the state climate summaries. So if you Google state climate summary, it brings you to this page here. And, you know, we select a state, we go to Vermont, for example, and what we can look at are the various messages. We can look at the various figures. So if you wanted to look at it on a temperature perspective, for example, either by summer or by winter, or if you wanted to look at it on an extreme precipitation, we could look at it that way. You have the ability to download these images and bring them into presentations that you may be looking at in here. And again, this is the one that is being updated as we speak. So if we need to actually have something for the next little bit, please let me know. I'd be happy to be that portal to help move this up a little bit quicker. So that's the first slide. That's the state climate summaries on here. Second site is the National Climate Assessment, and a really, really rich site. Again, drop-down menus. So if you wanted to look at the Northeast, it takes you to a lot of the things that we looked at in the Northeast itself, including a lot of those diagrams that I showed you before. So that's the second resource that I wanted to share with you. The third resource is this Climate Explorer resource. And when you Google Climate Explorer, look for the one that says NEMAC in it, NEMAC, because that's the one that's going to take you to this particular site that allows you to sort of drill down. So if I put in Montpelier in here, Montpelier, Vermont is the first one that comes up, and it allows me to do a number of different things. So for example, I can look at historical thresholds in here, and I can look at, you know, precipitation in particular. I can try and change the values. So if I wanted to look at what happens if, you know, I set a particular threshold and then go to any one of these dots in here, what it would do is it would show me what those values are, in this case from 1950 to the present. So that's the ability to actually sort of look at past values if we were interested in that. I can also look at projected values, which is what these climate charts up here are showing you. So again, because we're particularly interested in water resources, I can do a number of different things in here. I can either look at the total amount of precipitation at Montpelier, or I can do thresholds like number of days that are above either an inch of precipitation, 2 inches, and 3 inches, and so forth. So we've got that ability to look at extreme values depending on how much precipitation we're particularly interested in modeling. And again, the ability to download this and bring this into either a presentation or to bring this into one of the models that you might be running, because you can pull this down as either a CSV file or an Excel file. And then the last one I wanted to leave you with is the NOAA Atlas 14. So again, if you Google Atlas 14, it'll bring you to a map that looks like this. And again, if you click on the state, we're able to delve deeper into some of the values that are available. If you want to look at specific stations that you are modeling or working on, you've got the entire list of stations that are available here to choose from. Or if you had a specific lat and long, you could put that in. And then what it's going to give you are values that you can use for things like either culvert sizing or other model type values where you need a specific amount on either a given time frame. So whether it's how much rainfall or precipitation is going to fall on a 5-minute time frame, what the recurrence interval is. So here's the 100-year value for 5 minutes and so forth. And you can also get that information on a graphical perspective. So if you needed to have this on a time series, you also have that ability. So I think those were some of the things that I wanted to share with you as part of all of this. So I'm going to go ahead and stop sharing my screen here so that I can see if there are any questions or concerns. And I know I threw a lot of stuff in there, and like I said, I promised you it was going to be a fire hose, and happy to answer any questions that you might have at this point.
Any questions from the group? Ryan?
Thanks. Sorry, I'll work to take myself off mute here through a series of different options. Thank you so much for the presentation. It's very interesting and engaging. I was curious, this concept of ecological drought, the series of droughts and surplus rain we've seen, but seems more persistent droughts recently. Is Vermont seeing any impacts that are being studied or attempted to be quantified? Or has it experienced any recent impacts using that lens to look at the recent climate patterns?
And that's a great question, Ryan. And the answer is no, because it's so recent. Actually, one of my students in my class last week, her term paper was on ecological drought because she was so fascinated by it. And she was looking for stuff to put in her paper, and there's nothing written because it's so new. So I think it's one of those things where it's super awesome to be cutting edge. And because, from my understanding, a lot of the work of this particular working group might have some of that as a focus, I would be happy to try and have that student liaise with the group and share some of the things that she was able to find in terms of resources, in terms of thinking, because, you know, it is so brand new, there's nothing that's been done for the state. But as you delve into it, it's like, oh, doesn't that make perfect sense? That you're trying to do rights and use and where the water is, but nobody's looked at it like that, right? And so it's like, why aren't we doing some more of this? And so I will ask if she'd be willing to share her paper with you, so that you can actually get a lot of those resources or maybe some of the things that she was able to find.
Great, thank you. I think that'd be very interesting if she's willing to share.
Okay. Absolutely.
Other questions?
What
John?
I'm gonna do, I'm gonna try and pop some of these in the chat as we while they're still open here.
Yeah, thanks, Jeff. So thank you very much for your presentation. It's really helpful. So, and it is a fire hose, so I think we all need to think a lot about what you said. But I was just wondering if you had any, as you know, this is sort of the first kind of substantive meeting we're having. We're just starting to dig into these issues. I mean, do you have any advice for us, like based on the data that you've looked at and just some of the issues you identified as we go forward of things to focus on, just kind of as we're getting out of the gate? And then I think we may want to have you back at some point as we kind of narrow the funnel into thinking about what we want to recommend. But do you have any advice for us just starting out, where we should focus?
And so, John, I'll turn that question back to you because if you could give me the elevator speech for what the 2-sentence is for the group, that would help me with the advice piece.
Well, I could give you my perspective. Jeff, he's our fearless leader, so he may want to do it. But Jeff Crocker, I mean, Jeff Nelson's also a fearless leader, but I don't know if he's our fearless leader here. But I think the elevator speech is the legislature recognized there are concerns about water withdrawals in Vermont. Recognize that we don't have a lot of good baseline data in terms of how extensive those withdrawals are and what they are, and charge this group with analyzing what we know and don't know about withdrawals, what the potential environmental impacts are, and make recommendations for implementing policies to try to address issues that we identify as part of this group. So that's kind of my view of it.
Yeah, John, I think that sums it up. To look at the current and projected use of Vermont surface waters through water withdrawals and, what the economic, recreation, environmental impacts of that use may be, and whether it should be regulated or the policy around our water use.
Okay. So I would say, given that couple ways of thinking about it. First, maybe divide and conquer, because there are at least, what, 8 or 12 on the group, right? I would
Yeah, there's
say
10.
there's 10. Okay, I would say the first thing would be to see all of the various sectors that use our surface waters and have all of those either thought of or represented, so that once you start moving on from there, nobody's being left out. And then from there, the other thing would be to look at it both from a seasonal perspective, because the water withdrawals are going to depend on whether we're looking at snowmaking, for example, or whether we're talking about irrigation for ag. So sector-based, seasonal-based, go back as long as is feasible, as is realistically possible. So definitely more than 10 years, definitely more than 30 or 40 years, because we've gone through times of high precipitation, low precipitation, and high precipitation. So we want to get that full range of all of the water withdrawals that have been taking place both in previous droughts. And when I say previous droughts, I'm talking 2016, I'm talking 1960s, I'm talking 1930s, right? When the state looked different in terms of the vegetation cover. And so we need to bring in all of the aspects in terms of how does water get into the surface waters, right? And so if you're deforested, it's going to have a different trajectory than if you are reforested. So going as far back as possible would be one way to do that. And then it's a little bit more challenging now that we're in a virtual perspective, but to the extent that we can have a big whiteboard where you can put all those things, and I know it's going to be messy, but at least you will have them there. And then you'll be able to kind of move those virtual stickies around so that you see where the natural linkages come in. And because I've learned about ecological drought, this is going to be my new lens, right? Because it's the way that we can actually look at all of the aspects of not just the pure physical system, not just the human system, but how they kind of come together like this, right? In a way that makes sense for us here in the state. So like I said, I'd be happy to connect my student to help her share some of those resources. Because this is the second meeting, it's kind of great to actually be doing that now to help frame up some of that. And I just saw Carrie, so hey, Carrie. Okay, I hope I answered that question.
Yeah, no, thank you very much. This has been all very, very helpful. Thank you.
No problem. Carrie has a question, I think.
Yeah.
I do. Good afternoon. It's always great to see you again.
Likewise.
My question, I think we have a real interesting opportunity in front of Vermont. When I look at other nations and other states in their effort to address water availability that may affect water diversions, there's been some real, I think, science-based, innovative ways at looking at this question. South Africa comes to mind, where they predetermined how much water is necessary to have within the river systems themselves to sustain the ecological conditions of those water systems, and then determined seasonally what would be the availability of water for water use. Similarly, other states have also grappled with this issue. Massachusetts comes to mind, where they learned the hard way when they've diverted water out of basin, or when they've paved over one of their largest aquifers. They've learned the hard way in terms of how to really think about water recharge to be able to sustain rivers in their recharging from their groundwater aquifers. So I'm very interested in what we can do here in the state, and in subsequent to our first interbasin transfer. How can we take advantage of some of a different way of looking at water and its use, so that when we have situations such as drought or other climate driven stresses on our water systems, we're best prepared.
Right. Excellent question, Carrie. And I think you have the answer in your question itself. It's learning from other places because there's no need to reinvent the wheel. And from the get-go, having that perspective that we need to plan something that goes in both directions, both the ability to capture and store excess precipitation, but also release it when it needs to be released, and also to plan ahead for when we have drought. And so I might even go as far as to maybe try and get the charge amended a little bit from only surface water to having surface and groundwater be part of that equation, because the surface water, sure, it's the overland flow piece, but there's also the recharge from the groundwater perspective. And so that's where I think some of that systems thinking probably would be great, because your surface water has to have some kind of base flow conditions, right? And so for us to do your base flow, we have to talk groundwater. So I think to the extent that we can actually get the whole hydrologic cycle in there would actually help with doing that proactive piece of planning ahead for when we do have lack, right? So I think, like I said, the answers are in your question. The only piece that I would add is making sure groundwater is part of the charge itself. I hope I have not taken up your entire meeting. I wasn't supposed to.
No, thank you for your presentation and staying extra time here. I knew you had a time crunch, but appreciated to stay and answer some questions.
Not a problem. And I think I put in as many as I could. Let me see. There's only one last one that I will pop in here for you. It's the PDFs for the Atlas 14. So there we go. Okay. So everybody's got my email. Please don't be a stranger. If there's anything you need, just feel free to reach out. I'd be more than happy to come back, chat, brainstorm, sticky note, whatever would be helpful.
Thank you.
Not a problem. Thank you. See you, folks.
Thank you.
Bye.
Nice to meet you all. Okay, take
Thank you,
care.
Leslie.
See you, Carrie. Bye.
Bye. Okay, moving on in our agenda, we've got Mason Overstreet with Vermont Law School with us, who's going to give a presentation on some of the work the environmental clinic did on how other states are approaching regulations of surface water withdrawals. Mason?
Thanks, Jeff. It's a pleasure to be here. Just so it's at the top of the chat, just really quick, I'm going to pop in a report that our clinic recently published on this issue, which is kind of a nice thing to follow along with. Good to see everyone. I hope everyone's enjoying the beautiful weather. And yeah, Jeff, thanks so much for allowing me to be here. It's a privilege. So like Jeff mentioned, what I'm going to do is I am going to run through kind of a 30,000-foot flyover of what other states have done and how they have looked at this issue and how they've tackled it, and kind of existing regimes that are out there. And before kind of I dive in, I think it would be helpful, if my memory is correct, I think it was March 15th when Jeff gave a rundown of kind of the existing, I think it was March 15th, Jeff, is that about there?
I think you're right. Yeah.
Time flies, but Jeff gave a really nice overview of the existing regulatory regime in Vermont. And why that's important to what I'm going to talk about is it's important to keep, I kind of see it in basically there's two silos. There's a body of law that we call the common law as it relates to surface water diversions. And then there is this regulatory body of law house under ANR, which Jeff ran through. And both of those, again, are important just as kind of a placeholder when we start looking at other systems. But first, so the common law is this body of law called riparian rights, and it's derived from Old English law. And specifically, under riparian rights law, there's a rule called the reasonable use doctrine, and that's applicable right now to those diverting water or those withdrawing water along a stream side. And the way that rule works is that riparian landowners can use water, in our case divert it, so long as that use is reasonable and it doesn't interfere with others' reasonable use or the public's use. Now again, why that's applicable here is that it's an adversarial system, and so the only way for a riparian landowner to get relief or a remedy if there's a dispute is to bring that dispute to a court, right? So it's reactive versus proactive, and it is adversarial, and it's slow. The common law evolves over time, and it's very case specific, okay? So you have that silo just to kind of set, we'll put it in the parking lot. The next body of or kind of applicable regulatory regime, which Jeff touched on, is a handful of regulations housed under ANR, which distantly touch on surface water diversions. And there's only one in particular, which Jeff Nelson is an expert on, which directly touches on surface water diversions, and that's the snowmaking rule. And so the ski industry in Vermont is the only industry that's directly regulated for withdrawing surface water for snowmaking. So again, we'll take those kind of two silos, put them in the parking lot, and now we'll move on. But the one thing I was going to ask, and I should have said this at the beginning, is now having been on these Zoom calls for over a year, I find it a lot more, I find it better not to have a PowerPoint, just because the moment someone puts up a PowerPoint, it's easy to kind of check out. But if anyone has questions, please jump in immediately, just so we can have a conversation about the issues. Any questions thus far? Okay. So the next issue to kind of cover before we jump into what other states have done and what other regimes are out there is basically, generally speaking, we're talking in broad brushstrokes, but you can break up water law, water rights into kind of two geographic areas, the West and the East. And in the West, there's a system called prior appropriation, and it has a rule called first in time, first in right. That system, for a variety of reasons, is not really applicable at all to what we're dealing with here in Vermont. And so we're also going to put that in the parking lot, but it is good to recognize it and to be aware of it. In the East, predominantly, there are two systems to be aware of and that are relevant for Vermont to think about. One, the first is the riparian rights system, which I mentioned earlier, which Vermont is a riparian rights state. Now, it's not a pure riparian rights state because of some of these kind of piecemeal, there are some regulations that touch on surface water diversion, so it's not a pure state, but it is a riparian rights state. The second is a system called regulated riparianism. And that is actually the more predominant system in the eastern United States. And now, if you look at the states east of Kansas, roughly 19 of the 31 states in the east have developed, adopted, or enacted some type or form of regulated riparianism. And just to rattle off kind of a few states, those include Alabama, Arkansas, Connecticut, Delaware, Florida, Georgia, Hawaii, even though it's, out in the ocean, Iowa, Kentucky, Maryland, Massachusetts, Michigan, Minnesota, Mississippi, New Jersey, New York, North Carolina, South Carolina, Virginia, and Wisconsin. And so that's a lot, right? It's a mouthful. So actually, Vermont is in the minority as a riparian rights state and not a regulated riparianism state. Now, kind of an interesting footnote just to zero in on is that some of these states, which we're calling regulated riparianism states, do not actually deem themselves regulated riparianism states, even though they use the name, okay? So there are states like Connecticut where the Connecticut Supreme Court has actually named the phrase regulated riparianism for its system, you know, and adopted that formally, whereas other states have a regulated riparian system, but they don't completely name it, okay? Also noteworthy is basically, so under the regulated riparianism system, which I'll get into, there's a model law that the American Society of Civil Engineers has put together, and that's called the Regulated Riparian Model Water Code. And it's kind of this all-encompassing example of what states could do should they decide to adopt and or amend their current systems. And I've recommended to Jeff, there's a professor emeritus from Villanova, and Jeff and I were joking, but I actually call his name is Professor Joe Della Penna. I call him kind of the E.O. Wilson of water law. He is the official, he is the true expert. He wrote the model code. He is arguably the #1 expert on regulated riparianism and riparian rights. And I've recommended to Jeff that he come speak to this study group, you know, to actually go more in depth into the model code. But anyway, it's good to know that the model code is on the side, okay? So now if we zoom back out, so again, we know Vermont is a riparian rights state. It's one of the few remaining riparian rights state, as I mentioned. Predominantly in the East Coast, you have regulated riparianism states or some form thereof. One footnote also that I should mention that I forgot. Interestingly, there's actually a handful of these regulated riparianism states that haven't fully enacted their systems. So they have them, but they haven't implemented them, and they're not administering them, like Virginia being one. So there's a few kind of outliers, but I want to mention that as well. So before we dive into state specifics, basically the concept of a regulated riparianism system, which sounds scary at first, but isn't once you kind of get into the nuts and bolts, is that the riparian rights system remains in place, right? So that old riparian rights system remains in place, but it's managed through this umbrella administrative system that serves not only to protect public interest, but also the rights of users themselves. Okay, and if you look in the report that I posted in the chat, we have a pretty quick, again, flyover summary of some of the benefits of such a system, you know, for businesses and folks actually performing water diversions, like certainty, predictability, reliability, consistency, etc. Right? Whereas at first glance, some might not think that would be the case, but it is. And there's a lot written on this as well. So again, before we get into the case to kind of the state specifics, the other thing that I thought would be worth mentioning, most of the state statutes that have these systems in place, right, they have a declaration of policy or provision at the beginning of the statute, which kind of lays out the purpose. And most of them follow this list, which I'll just read, just so we're all on the same page. And first, it involves conserving water and other resources, promoting the beneficial or efficient use of water, ensuring that the use of water is consistent with public interest, ensuring comprehensive state planning, protecting water supplies, preserving minimum stream flows, which Carrie had just kind of touched on in her previous question with our earlier expert, promoting flood control, allocating water during times of shortage, regulating interstate or interbasin diversions, which this study group is tasked with looking at, and coordination of water allocation and water quality regulation. So here we're really talking about water quantity, not water quality. And in Vermont, the majority of existing regulations pertain to water quality. So picking from states that Vermont could kind of glean from and particularly take away lessons learned when just thinking about what existing systems are out there, and is there a plausible solution to what Vermont is facing as far as climate change, the effects of climate change, erratic, unpredictable weather, paired with increased industrial uses, we looked at a handful of states and selectively chose them. And we looked at Minnesota, we looked at Florida, we looked at Massachusetts, Connecticut, New Hampshire, and Hawaii. And what I'll do right now is I'll just give kind of a quick flyover, and if anyone has any questions, we can kind of zero in. I'll stay away from some of the real nitty-gritty details, but just know that the regulated riparian systems, how I like to, kind of the analogy I like to use is the model code that I was referencing earlier, which Professor Joe Della Penna wrote, that model code comes with a lot of different levers. And depending on what the state decides to enact or adopt, at times the state can pull on different levers depending on the situation, right? So there are things like climate resiliency plans, which you can bake into a system, and minimum stream flows, water quality issues, et cetera, if that makes sense. So I just always kind of use the lever analogy. Any questions before we kind of go into state specifics? Yeah, Carrie.
Trying to find my hand. Just quickly, before you dive into the details, why these 6 states?
Oh, so good question. These 6 states, a handful of them are known as the more successful states, Carrie, and then also some of the others that we selected, for example, Hawaii and Florida. They have really interesting concepts that Vermont could use potentially and or think about if it were developing a system. So like, for Florida and Hawaii in particular, I'll talk about it, but they have these water management districts that kind of resemble the Act 250 districts. And so why that's relevant is similar to what our previous expert was talking about, is there are going to be parts of Vermont which may be water flush, and then other parts, right, that are really struggling. And so water management districts are a concept that can be advantageous, where if you have, again, areas that have, plentiful amounts of water versus others that are stretched thin. Okay. And then the other, Carrie, to finish off your question, the others that we chose, for example, New Hampshire, we chose New Hampshire because it's a neighboring state, and it too is thinking about, the same issue that Vermont is, right? There are other examples. So Maine right now is also literally thinking about the same thing. Michigan, for example, they have a system, but they're actually if I'm correct, they actually are looking into changing and or amending that system right now. So there's some other moving states that are too wrestling with the concept and the problem and the issue and how to resolve it. So any other questions quickly?
Have you got a battery charger? My phone.
So Minnesota, Carrie, going back to your question, like Minnesota is known as having one of the strongest, most robust, successful systems. It's kind of a bedrock one. And our recommendation to this study group would be, I can give a flyover of what these systems look like, but our recommendation would be for the study group to hear from agency staff in each one of these states, how these programs are operating, what are lessons learned from them, what are successes and failures, et cetera, et cetera. But so for Minnesota requires users withdrawing water of more than 10,000 gallons per day or 1 million gallons per year to obtain a water use permit. And permittees must submit these annual water reports, right? So the state kind of keeps track on the impacts. The Minnesota DNR they're authorized under the statute, which is important, to basically manage for multiple sources, including domestic, agriculture, fish and wildlife, recreational, power, navigation, and quality control. So it's kind of multi-resource. Minnesota, interestingly, also takes into account this interbasin transfer issue. And again, Jeff touched on this back in March, but just to kind of refresh, an interbasin transfer is a surface water diversion, right? It's a subset of a surface water diversion. And so in Minnesota, the commissioner of DNR can determine whether the water left in the basin of origin would be, quote, adequate to meet the basin's water resources needs during the specified life of the duration of the withdrawal. So they bake in the interbasin transfer issue, as do some of these other states as well. Minnesota, like, that's a brief flyover, but Minnesota is a well-known example of a successfully operating system that's forward-thinking, and has a it's a well-running administrative system. So the next one I'll mention, and these are in no particular order, is Carrie already previously mentioned Massachusetts, right? And Carrie gave a couple reasons. Like, Massachusetts has had some hard lessons to learn from, but they do have an existing system right now. They have a regulated riparianism system, and that system, kind of the purpose, they regulate withdrawals from surface waters for the well-being and safety of citizens, protection of the natural environment, and economic growth. So they do name economic growth, which is important. And they implemented and adopted that system. Similar to this study group, Massachusetts looked hard into this issue before adopting it. And they heard from a bunch, they had a bunch of technical based recommendations to agency staff and the legislature. And they would be one too. And Carrie, I suspect that you have contacts there, but they would be one too that we would recommend hearing from agency staff. What's their, what lessons did they learn when they were looking into this? What lessons learned are there now that the system is operating? Their program began in 2014, and they have a registration program and a program for surface water withdrawal use. But again, just broad brushstrokes, it's a system that we would recommend that the study group look into. Connecticut, similarly, has a statewide well-operating system. Again, this is from an academic perspective, so I can't reiterate it enough. I think it's really good to hear from agency staff, boots on the ground, what it's really like, and users too, right? So those who are applying for surface water diversion permits. But in Connecticut, all diversions that are 50,000 gallons or greater in a 24-hour period require a permit. Why Connecticut is in particular kind of interesting, and there's some useful things to kind of glean for Vermont, is flexibility, right? So I was talking about earlier about areas of larger areas where there's more plentiful surface water, whereas versus areas that are strained. Connecticut has flexibility in that the permit request, those diverting water, they have to, in their application, explain the need, the reason for the diversion, the description, actually of the current water, they have the description of the current water system, location of the withdrawal, quantity of the withdrawal, effect of the withdrawal on water supply. They have to think and look at alternatives, which is kind of interesting. And then they also have to think about conservation measures considered, right? And then the commissioner in Connecticut can impose additional permit conditions, including duration if necessary. But I think the key point, the kind of key takeaway there from Connecticut is flexibility, right? But also there are some interesting concepts thinking about alternatives, conservation measures, impacts of the withdrawal, et cetera. So jumping geographically, the next one to look into is Florida. And again, here, fully recognize Florida is very far from Vermont. It's a different state. It's a different water state. I'm sure all of you are aware of some of the complications that Florida has faced, regarding water. But why it's interesting and relevant here, primarily from our perspective, has to do with these water management districts, which I mentioned. And so there, the Florida DEQ, so Department of Environmental Quality, they basically delegate their water management authority in their system to 5 water management districts. And those water management districts, kind of like the Act 250 districts, then they regulate their specific region, but each region is regulated in a different way depending on the water availability. And so decisions in each water management district are, again, based on water availability in the particular area. Each water management district also has its own plan for water sources to address water supply, water quality, flood protection, floodplain management, and natural systems. And during times of shortage, how earlier I mentioned kind of the analogy of levers. So these water management districts have contingency plans. So in times of shortage, they can shut a lever off, right, if there's a problem. Also kind of relevant and going back to a point that Carrie made with the previous expert, is that these water management districts, they also establish their own minimum flow and minimum water level for surface water resources in the area. And so again, not saying the entire system in Florida is what Vermont should look to, but I think the concept of water management districts is something, especially with Vermont being a state, that has high populations, for example, in Chittenden County, low populations, for example, in a place where I live, I live in East Barnard, so where population is not too high. That's kind of the flyover of Florida. Any questions there? Yeah, Carrie.
I will find in this team my hand, but I was curious to know whether you want to take questions on the set after you finish the flyover or specific to Florida, for example, as we.
Oh gosh, Carrie, whatever the group prefers. I mean, I can quickly finish off. I can quickly talk about New Hampshire and Hawaii, and then we can run back to questions if that works and kind of tie them all together.
I think that works. Yeah.
Yeah, and I want to be mindful of time. I'll do that quickly. So we'll jump to New Hampshire. So again, going back to Carrie's previous question, why did you choose these specific ones? New Hampshire borders Vermont. It's a neighboring state. Similar geography. Actually our previous expert, some of her data, if you noticed, also showed New Hampshire. They're dealing with similar problems, and so that is why we looked at New Hampshire. They have a fairly evolving system. They require diverters who withdraw 20,000 gallons in a day or 600,000 gallons in 30 days to obtain a permit. New Hampshire DES is tasked with setting the permitting requirements, including conditions, length, et cetera, and some of those levers. New Hampshire system, again, it gives the state a little bit of flexibility as far as adapting to changing needs of the state, and it allows it to have some discretion as far as related standards. The other thing that's kind of worth mentioning in New Hampshire is I'm sure folks are aware that they have this pilot program which started on several rivers and has now expanded, basically where they're looking at in-stream flows and they're tracking how to ensure to maintain healthy, balanced ecosystems with robust water supplies for drinking water, business, and off-stream uses. And so that's something to kind of zero into. And the pilot program has been pretty successful and also pretty illuminative on impacts and also kind of how to resolve the problem. Last is Hawaii. Similar to Florida, kind of we'll put it out here in left field, but it's worth mentioning. Hawaii has a pretty fascinating program, which I won't go into full deep detail, but they have this regulated riparianism system, which actually is paired with native Hawaiian water rights. But the code, their code provides for adoption of a state water plan and protection of in-stream uses and designation of water management areas. Basically, when existing withdrawals exceed the appropriate sustainable yield. So again, when we think about climate change and the effects of climate change and some of the things that we heard from the previous expert, you've got to think about uncertainty, unpredictability, and being maneuverable, right, and malleable. And Hawaii's program does have that. They too, interestingly enough, like Florida, have the designation of these water management areas, which replaces the common law and requires users in those specific areas to obtain a permit similar to regulated riparianism code, you know? And so that allows the agency to set these water management districts in areas of high water use where competition is really high, and avoiding kind of the burdensome regulation, which I was talking about earlier, in areas with plentiful water. Again, I would put Hawaii and Florida kind of in the same bucket to think about and to kind of think on some of the concepts and maybe have conversations with agency staff, but not particularly, you know, the as far as thinking about the perfect system for Vermont. It's more concepts within the system of Hawaii and Florida. So that's kind of the quick 30,000 flyover. I appreciate everyone's patience, and I know that was fast and probably a lot to take in. And yeah, Jeff, now maybe we can go back to any questions anyone might have.
Yeah, anyone have questions? One thing I'll mention is I have started reaching out to some of the states regulators that, you know, New Hampshire, Minnesota, Massachusetts. I know the regulators and work with the regulators in New Hampshire, so I think I can get them to come in to talk a little bit about their system and how their in-stream flow water availability reports in a basin work with their water withdrawal program. It's an interesting thing that, as Mason said, is evolving over there, but I believe I can get a couple members from DES to come in and talk to us. Carrie?
Thank you, and thanks very much for bringing this report to our attention. I very much look forward to diving into the details there. So I truly appreciate that. And I also appreciate that you've gone through in more depth the nuances pertaining to these state models. So I thank you for that. I think what gives me a little bit of heartburn, though, is in recognition that some of these states that you've identified do not have good reputations for water management. You take Florida, for example, where we have the Everglades, which is an ongoing problem in trying to determine how to best restore water, redivert the plumbing of that Floridian landscape to restore the Everglades. You have South Florida, where you have a kind of a salty increase in saltation in the South Florida Bay. And a lot has to do with not enough in-stream flow to help with that flushing value. With respect to that first one, you have water. The plumbing is actually sending water to the ocean and not to regenerate the Everglades. And then you have on top of that water quality challenges associated with the water uses. And so without going through some of the other challenges that other states have faced, there are some important lessons learned, which just gives me a little bit of heartburn in using some of those states. I think learning from those lessons learned, that is critical for our work, because I think we're at a stage where we can, being somewhat rural and not with a population demand quite yet on our resources, we have the ability to learn from these other states. And then, although while Western has that appropriative water law, they have fundamentally driven by consumptive use, overdraft, and the pricing of water. They've moved in a substantial way, being somewhat driven by their drought-stricken areas and the value of their agricultural use to conservation, to achieve maximum conservation in where we have public consumer use. So I think there are some important lessons learned even in that Western context. I agree not to use the appropriative water rights because they've promised away more water than in the system. So that's not going to serve us in the long run. But anyway, I just wanted to flag that for, I'd love to just hear your reaction to somewhat my cautionary instincts.
Well, Carrie, first and foremost, thank you. And I also will say, as far as the report goes, if you have any questions when you do delve into it, please let me know. I'll put my email in the chat. As far as your comments go, I'll just say we completely agree. We 100% agree. The only reason we named some of the states, which you kind of alluded to, is purely for concepts. So as Vermont starts to think about concepts and what concepts are existing and what are out there, I do think there's some lessons to glean from systems such as Florida, like I mentioned regarding the water management district, purely to think about, you know. So by no means are we naming that that's a perfect system. We're just extracting a concept and saying this would be something for Vermont to consider as it kind of marches down this path. So I appreciate that you kind of clarified that.
Jeff Nelson?
There's the mute. Thank you for that. I had a question I wanted to ask about the report itself, if I could. Just curious, I didn't find any mention at all in the report of the Vermont water quality standards, and I was curious why not.
Yeah, I mean, Jeff, good question, and Jeff and I have spoken offline about this. You know, Jeff's summary and presentation back in March kind of hit again on, we'll call it like the scattered regulatory regime in Vermont that's existing, taking aside riparian rights law. And we didn't mention the water quality standards, Jeff, primarily because, again, you know, the water quality standards, they focus on water quality, but not water quantity specifically, you know?
Well, I guess I'll take issue with that. I don't know if you've read the standards recently, but are you familiar with the hydrology policy of the standards?
Jeff, if you're I mean, I don't have it in front of me. I am very familiar with the standards, and I do remember, if my memory is correct, Jeff, when we testified in front, when H33 was in front of the House Natural Resources Committee, you know, you touched on some of the policies related to water quality standards, which we fully recognize. But again, as far as water quantity goes and those diverting water specifically for water withdrawals, that's really the reason we did not dive into those fully.
Okay, but I guess if you look at the hydrology policy, which is on page 10, you'll see that it specifically mentions dams, diversions, and other control structures. It also says these rules, in conjunction with other applicable law, provide a means for determining conditions which preserve, to the extent practicable, the natural flow regime of waters. So it is expressly speaking to quantities of water, management of flows, and protection of stream flows. So I think there's a little bit of a disconnect there with your paper not noting that at all, because I think that's a pretty overarching and comprehensive statement of policy by the state of Vermont.
Oh, Jeff, I appreciate your point, and respectfully, again, we more see that as a policy related to large scale projects, which Jeff kind of touched on back in March. and you touched on in your presentation last year. But we very much appreciate the point, and I appreciate the back and forth.
Thank you.
Carrie?
Just to follow up on Jeff's comment, there's associated hydrology criteria on beginning on page 23, too, just flagging that relating to water levels, flow. So I wanted to just make sure everyone was aware of that language.
Yeah, and I guess my only point in bringing it up is that I just want to make sure that the members of the group are aware of that, and that, you know, my point is that we're not starting from scratch, in that there are some policies and you know, some thought that's been given to you know, protection of stream flow in Vermont.
And Jeff, I would just respectfully say, again, I appreciate you naming this. I appreciate you naming it last year. We see that more as a policy and agree with what Jeff said back in March, and primarily see the riparian rights law as the primary body of law governing or applying to those diverting water.
Well, one thing to clarify, you know, I mean, the hydrology criteria is what we use to set our in-stream flow, minimum flow, you know, for hydroelectric projects, for projects requiring a 401 water quality certification, and in general have that body that regulates stream flow. And just to provide a little background on where that came from is in the 90s, I think it was 97-ish, you know, the EPA said to the states, you need to think about water quantity, not just water quality and your water quality standards. John?
Yeah, I mean, just to jump off of that point, I think Jeff Nelson is right. I mean, the hydrology criteria is there, and it's certainly used in hydroelectric permitting. It's certainly used, I'm sure, when the agency evaluates waters to determine if they meet water quality standards and to see if there are flow-related impacts that are, you know, harming, you know, that are causing waters to not meet water quality standards. But I think the gap is in jurisdiction, right? So it's where the policy gets applied is definitely with hydroelectric facilities, definitely with ski areas and snowmaking, and then the rest is really scattered. So, you know, I look at this effort as, you know, getting ahead of just like when the agency staff evaluate waters and identify a flow problem, you know, what are we missing in terms of having oversight so we don't get to that, you know, we don't get to that point. So I think everyone's right in my view. I mean, I think the policy is there, and I think it certainly informs today how we look at streams and rivers and surface waters that meet water quality standards. But we have very limited levers right now of jurisdiction, you know, to address activities that are affecting flow.
Can anyone hear me? This
Yes,
is David Dean.
We can hear you, David.
Okay, I'm sorry. The system, whatever is going on, I've been here for a long time, but I want to address this point. And Jeff, it's one thing to have that standard in the water quality standards because it's the backdrop, the context against which permits are judged. And 401 was mentioned, discharge permits, other diversions, but part of what we're talking about here is the lack of jurisdiction, and John just brought that up, so that we have situations that aren't applying for a permit and against which that backdrop, that context of the water quality standards does not apply. And I think this group is charged with determining whether that is of sufficient concern to do something different so that those standards and the water quality standards apply to all impacts on the surface waters of the state.
I don't know if I should raise my hand every time I want to
Jeff,
speak. But
yeah, no, you go ahead, Jeff.
I thank you, David and John. I agree. I think that I just wanted to make sure that folks were aware that there was this policy backdrop, because I think it's important. And I think what the jurisdiction is definitely something that we need to talk about. I will say, though, that the agency does have the authority to enforce the water quality standards, which includes flow, against any person. So if someone was, drawing the West River dry or doing something, and they didn't have a permit, the agency could enforce against them. So there is, there is some. I realize that's a clunky way to do it, and it's not where we want to go, but I do think that there is some backdrop that exists currently.
Right, and Jeff, I think that's what 10 VSA 1258 gives the agency the authority to enforce the standards.
Yeah. Anyway, so I think we're all sort of saying the same thing.
Any other questions? Carrie?
Just a couple of things I just want to throw out since we have an academic in the audience here with Mason's involvement. My question is about, and with Leslie Ann's comments, is about the impacts of climate and the whole non-stationarity issue that is certainly a major part of this issue that we're confronting, and that you can't necessarily rely on historical data to determine your future use. So there's already an inherent uncertainty related to that. So I'm very interested to get a sense for whether you're aware of any states really grappling with this problem through the concept of adaptive management, so that we can, I know that there's, because of that blatant uncertainty, not to create new uncertainty, but but to really kind of recognize that what we need to do and whatever we forward is include some sort of concept behind an adaptive management approach to ensure that we're achieving the ecological health of our landscape.
Yeah, thank you, Carrie. I guess that I can't tell you any specific ones other than Minnesota. And Carrie, what I think we should do is, I think that question would best be put to actually Professor Joe Della Penna, when and if he comes and speaks to this study group, just because he does have a better temperature on, he stays in touch and directly monitors what all the different states are doing. And so, I mean, while I can kind of generally answer that, I think we should put it to him. Yeah, I think he'd have a more specific answer.
Thank you.
Any other questions?
I have one more.
Take care.
Again, and maybe this is more of a reaction. But I do want to just flag just an inherent concern I have, again, getting to a question I had asked Leslie Ann about this, is that the concept behind adequate in-stream flows to determine the ecological health prior to actual diversions, as opposed to the other way around, where we're allowing incremental diversions, hoping that our anti-degradation policies of the state will, or our 7Q10 determined by old data, is going to save us, when love to try to think about something a little bit more proactive and how we can come to terms with that kind of overarching need and goal here. I'm happy you didn't mention Georgia because when you see Georgia's reaction is just building more reservoirs, for example, is again not a direction we necessarily want to go to when what we want to be thinking about is mapping our aquifers, conservation, determining what those needs are, in-stream flow requirements seasonally, building in adaptive management with a climate change future, something that we can lay out that is less about an engineering approach towards solving everyone's needs or demand, but something that's built, the science behind adequate seasonal in-stream flow is fundamental to what we're trying to achieve here.
Yeah, and Carrie, that's largely, when we're working on hydros or even working with Jeff Shops on snowmaking, is we're applying, depending on the biology that's in the stream and the habitat, we're applying seasonal conservation flows. So, with snowmaking, we have the February median flow, and when water levels drop below that level, all withdrawals have to stop. And it's similar, when we're working with a hydro, and water has to stop being diverted once you get below that conservation flow and your minimum capacity. But I think we do have a good framework for that in Vermont, and we've done a lot of work on we've have seasonal conservation flow values, and we've applied them. It's just being able to apply them in all situations is maybe the jurisdictional issue.
Thank you.
Other questions? Thank you, Mason, for presenting and the environmental clinic's work.
Oh, hey, thank you for having me, and happy to help. Yeah, great to see everyone.
Thank you very much.
Okay, time is getting a little short, but I'm going to try to do this. Our fourth agenda item here is the overview of the regulatory review of interbasin transfers in Vermont, as the agency has done it in the past. I'll present how we did this related to the only interbasin transfer we have, which is the Killington-Pico interconnect for snowmaking, which Jeff Nelson's team was the lead consultant on for Killington. So I'll invite his perspective as well as I walk through this. Oops. Okay, so one of the goals and duties of the study group is to recommend whether or not surface water transfers between watersheds should occur. As I mentioned before, there's only one interbasin transfer in the state that I'm aware of, and that was the Killington-Pico. So what I wanted to do is give an overview of how the agency walked through the the analysis of when this proposal was put forth in the existing regulatory framework that we used. And then we may not have a time for a complete group discussion, but get some of the group's thoughts on the regulatory framework and its adequacy for addressing the concerns with interbasin transfer, and how maybe holes in it or how it can be adapted. So the main vehicle that we used in evaluating them is the Vermont Water Quality Standards, which defines the goals and the uses of the waters and sets criteria necessary to protect these uses. The overall, when I think about the water quality standards, there's three components that are largely in this group. It's the physical, the biological, and chemical components all make up the water quality. So just a quick overview of the Killington and Pico snowmaking systems. The Killington snowmaking system has 4 surface water withdrawal sources and then 2 reservoirs with 1.5 million gallons and 24 million gallons storage. For the Pico, it's a smaller system with 2 water withdrawals and then 2 reservoirs that are roughly around 6 million gallons. So the interbasin transfer proposal that was Killington had was to construct an approximately 8,800 foot pipeline that would connect Pico and Killington snowmaking system. And the pipeline would transport water from Killington to Pico as needed for snowmaking. This is a transfer, as most of we know, from the Ottaquechee watershed to the Otter Creek watershed, which the Ottaquechee drains into the Connecticut River and the Otter Creek drains into Lake Champlain. Additionally, there's other more comprehensive proposal, but I think for the sake of this group, they also propose to increase the conservation flows to applicable hydrologic standards at the existing water withdrawals and modify the water management regime at Woodward Reservoir. So the existing regulatory framework that we looked at using the water quality standards, was protect the hydrology, the water quality, the aquatic biota, and the aquatic habitat. So the specific criteria for the waters of origin, these would be the waters on the Killington side, mostly when we're talking about the interbasin transfer, was to use the hydrology criteria of the water quality standards and specifically the stream flow protection criteria and the water level managed fluctuation criteria. And also using the applicable rule, in this case would be the snowmaking rule, which dictates how the agency will make determinations on minimum conservation stream flows at snowmaking withdrawals. For the receiving waters, those being on the Pico side of the mountain, we also looked at the hydrology criteria and the high flow regime criteria specifically. We looked at some of the water chemistry criteria and the aquatic habitat criteria in terms of the stream processes. We also used other applicable areas of law from the state, and that would be, no transport of aquatic plants or animals to limit the risk of introducing invasive species or nuisance species. So I'll walk through a bit more in detail of the regulatory framework for the waters of origin and specifically what those criteria are and how they were applied and the action that was taken. The first one is the hydrology criteria, and this would relate to the water withdrawals on the Killington side, Falls Brook, Roaring Brook, and the Ottaquechee, where the criteria is any change from the natural flow regime shall provide for maintenance of flow characteristics that ensure full support of use and comply with the applicable water quality criteria. The preferred method for ensuring compliance with this subsection is a site-specific flow study or studies. In the absence of the site-specific flow study, the Secretary may establish hydrologic standards and impose additional hydrologic constraints consistent with any applicable agency of natural resources rule or procedure to ensure that compliance with the requirements of this subsection. So, as I said, this was for a snowmaking facility. So the applicable rule applied here was the water withdrawal for snowmaking rule, which designates a site-specific February medium flow as the conservation flow for these. So Killington and Pico provided that information for their intakes that they collect, and we calculated the February medium flow, and that became the new conservation flow for that intake. For the water level fluctuation piece, and this would relate to Woodward Reservoir on the Killington side, the criteria is, water levels when subject to management, but only to the extent that such variations fully support the uses, and these uses being aquatic habitat, recreation, boating. And here, what Jeff's team did was do work on a littoral habitat assessment of the Woodward Reservoir and give us that data. And we developed with them a acceptable water level management regime for the Woodward system. The next I want to walk through is what we did in terms of the receiving side of waters on the Pico side. And of course, keep in mind that the receiving waters here wouldn't see the potential extra water in the system until it ran off in the form after it's been made into snow. So the first criteria that we applied was the high flow regime, which says no change from the natural flow regime that would result in runoff causing increase in frequency, magnitude, or duration of peak flows adversely affecting the channel integrity or preventing full support of the uses. And again, this aquatic habitat. So what Jeff's team did was conduct hydrologic analysis, melt analysis, looking at how potentially the increased snow from the Killington side may affect the magnitude or duration of peak flows that we would see on the Pico side. And then the resulting conditions that were included by the agency call for a runoff, management plan to help address any issues that this may cause. We also looked at the habitat use protection over on the the Pico side, as well as the Killington side, but the specific criteria that we were focusing in on the receiving waters was the stream processes and making sure that those stream processes were protected. And the stream processes, means the hydraulic bedload sediment and large void debris regime of a particular stream reach, and its term used to describe stream hydraulics or erosion, deposition, sorting, and distribution of in-stream material by power of flowing water. Stream process works towards an equilibrium are governed by flow characteristics, stream morphology, channel roughness, floodplain connectivity, in part determine the physical structure and aquatic habitat quality. So the action that was done was the applicant conducted a geomorphic assessment of the stream that would potentially have the higher volumes of runoff and assess the channel integrity of the stream. The condition that subsequently came through was an in-stream channel restoration, i.e. the replacement of undersized culvert that was under maybe an access road. The other portion outside the water quality standards, but still applicable and that we applied, was just ensuring that the water being transported from Killington to Pico did not transport aquatic invasives or nuisance species. And the action item here was a condition, requiring, a monitoring, identifying steps that the applicant shall complete, and immediately seizing the transfer of water to PICO if aquatic invasive was detected. So this is just a summary slide. So just for the waters of origin on the Ottaquiche side, conservation flows consistent with the hydrology criteria to support aquatic habitat. There is some seasonal aspects to it. One on the Ottaquiche just as another that part of their proposal, and receiving waters on Minden Brook or the Otter Creek side, that the flows not adversely affect channel integrity, water quality, or alter stream processes. Through the hydrology and geomorphic study and the runoff management and in-stream restoration measures. So that's all I had, and my goal and purpose, as I said, was just to try to get a discussion going with the group about this question that's before us, and start the conversation of recommending whether or not surface water transfers between watersheds should occur. So with that, I'll happy for questions or start answering. Actually, I'll Jeff give a little bit about how he working on this from your side, how your perspective on it.
Thanks, Jeff. No, I appreciate that. And this was certainly a novel situation in that in the first of my memory, as well as yours, the concept of an interbasin transfer being considered in Vermont. And I think one of the things that I learned, and I think you did a great job summarizing it, Jeff, is that in this context, where it was a snowmaking water withdrawal that was contemplated, we really do have, in my opinion, the right tools in the tool bag to be able to review such an application and ensure that both the sort of giving and the receiving waters are adequately protected, which is why I was asking the questions I was earlier about the consideration of the hydrology policy. I think that, through the 401 and the ability of the agency to insert some very specific conditions for protecting waters on both sides, and given the language of the standards, which enabled those conditions to be legally included, I think that we ended up with a project that achieves what Killington was trying to do, not only from the standpoint of providing reliable water for snowmaking, but also, remember, on the PICO side, there was a long-standing issue of insufficient flows in Minden Brook that had been listed on the Part F list of waters that were altered for flow for many years, and it was a really difficult nut to crack. I mean, we'd been kind of off and on working on this for 20 years, trying to find a solution to the water issues at PICO. So this provided a way, with the appropriate protections in place, to resolve that issue and make sure that we weren't creating new issues by virtue of transferring that water from the other side, by ensuring that things such as protection against invasives and looking at impacts of the changes in stream flows on melt events and the nutrient transport considerations were also evaluated and found to be within acceptable limits. So, I guess I know there was a lot of concern when this project was being considered because it was novel, but I do feel very strongly that given that it was a snowmaking water withdrawal, that the agency very much had the tools it needed to ensure there was proper protection. Had it been some other kind of withdrawal, I don't know that that would have been the case. So I think that this is an absolutely valid conversation to be having, and so that we can come up with hopefully some kind of a a unified recommendation. But I think in this case, because of the tools that were already available to the agency, we were able to, in my view, come up with a very protective plan. So,
David? Thank you, Jeff.
Yeah.
Yeah, Jeff, actually, Jeff squared, if you will, both made the point I'm going to stress. Snowmaking only. It triggered a environmental review, and having gone through the snowmaking wars at the legislature and ending up where we were, I still feel it's an adequate and very useful tool for both the interests of the waters of the state and for the snowmaking interests of the ski areas in terms of surety. But that said, Jeff, I sat at that table and I still remember you making the statement, we really don't need a 401 certificate to do this. You backed off of that pretty quickly, but that was a statement that was made. And it was the 401 that actually triggered some of the level of review that Jeff set out in his presentation.
Agreed.
So I just wanted to stress that, yes, it worked well because the people sitting around that table were of goodwill. But if any one of us had walked off and decided to apply all legal pressure, you guys would still be looking for a permit to be able to begin the development of that project. And it's because of that case by case by case approach that you don't have quite the surety that you might think you have. So hopefully we will address that as one of the results, products of this effort by this committee.
Thanks, David. And I think that, sort of speaks to a bit of the framework that Vermont has sort of existing potentially that we could look at as well as we work through this as a group. There is a snowmaking rules, as Jeff and you have said, they've worked well for that sector. And going back to one of our duties as a group is, 3B is how a permitting program would comply with Vermont water quality standards. And, identifying that if we have the water quality standards in place that we can adequately address these issues, or if we don't, what changes should we be thinking about as a group?
I know it's premature to be offering ideas and possible solutions, but I can't help myself. So one thing that we could have a conversation about at some point is if we are going to recommend that interbasin transfers be allowed, that a condition attached to considering that would be that any such activity would require 401. And there you basically open up the full review under the standards on both sides, the receiving and the sending side, as we had to do in the Killington-Pico case, because David is correct. Under the statutes and policies as they exist today, we could have made the case that we did not, and we talked about it at one point about not needing a 401 because of the particular circumstances of the project and the potential for not causing anything on a federal license or permit that would require a 401. So, it is just something I thought I'd throw out there while we're on this topic.
And I think maybe from what I've talked to with New Hampshire, we may be able to pull something about the way they regulate their water withdrawals is basically it's compliance with the water quality standards is the way it's written in their statute. And I think Mason brought up a component that Minnesota may be working on stuff related to interbasin transfers that may be interesting to hear if for the group or something. Other people have thoughts? Carrie?
Maybe we covered this at the last meeting, and I apologize if we had, but have we defined what we mean by interbasin? In this particular case, the snowmaking case, it just happened to be inner watershed and interbasin. What if the next project is an inner watershed within the same basin? So I just throw that out because there may be a size issue or that may cause the same sort of impacts in terms of the taking watershed and the receiving watershed.
That's a great point. The duty says transfer between watersheds. So how we define watershed on this will be important, because if you are talking about transfer within watersheds, I can think of more examples. Any other thoughts from the group or Carrie?
Yeah, so it doesn't have to be today, but I would love to hear more from both Jeff and maybe Evan, because we know how unstable our rivers have been over the last 300 years, and to understand just take Mendon Brook, for example. We know how unstable that stream is, and to avoid diving into the weeds, when we think about what are the impacts that we're trying to mitigate, and we have a stream that is incised, for example, would we be looking towards the restoration? What is the goal of that kind of restoration component to any given project? It's hard to, in other words, to separate the noise, the background noise of existing conditions, to the cause and effect of changes in stream recharge. So it's just something gosh, why maybe it does take a 401 or geomorphic assessments on a place by or example or project by project basis to try to get a sense for what our ultimate goals are per watershed.
That's a good point, and I can, happy to work with Evan on that. I think Evan's leaving.
Yeah, I
We
guess
are a
I
bit
just
over, but
time check. Yeah, what do
Yeah.
you want to do, Jeff, as far as that? Because I've got something else I've got to join as well.
yeah, why? I hate to. Sorry, we've gone over. We can try to pick this up. We're going to meet again in about a month. I'll send out the calendar, get some people lined up, and we can back up on our conversation. Again, I'll post the meeting recording to the website along with all the documents for people to use and browse as they need.
Are you going to send out a poll for possible dates, or I can't remember how you did it this time?
I was just going to populate on Mondays from 1 to 3 every third or fourth Monday of the month. It seemed would work. And that way we would just have them all populated on our calendars and just be ready to go if that still works.
Well, just speaking selfishly, if you could avoid June 28th, because I'm going to be out then.
Okay.
Thanks.
That sounds good. I think right now. Oh,
Yeah,
Sam?
I like the notion of having a regular day of the month.
Okay.
And Monday is fine. We're doing that mostly because of Chris and Carrie, but Monday remains fine even after the legislature adjourns.
Okay.
Yep.
Sam?
Yeah, I got a question. Do you see the possibility of us actually meeting physically in the near future instead of this Zoom chatting and stuff? It would be, I think, more beneficial to everybody involved, at least from my perspective.
Yeah, I mean, I guess I'd ask individually how people feel about that. And, you know, I think personally, I'm fine and going to be fully vaccinated. But, you know, we are still remote till September 1st as the state agency. So, you know, it may be closer to September before we meet in person.
What is our deadline again?
It's December, something around December.
Okay.
I'd have to go back, but yeah, it's a report due, I think, December 15th.
December 15th, 2021.
Yeah.
Yep.
I mean, I'm comfortable meeting in person, but I'm also comfortable with this. So whatever the majority
Yeah.
of the group wants to do.
Okay.
Do you
Or
want me?
whatever. I mean, I don't know what if you're even allowed, Jeff, to convene.
I don't know either. I don't know either, and that's something I need to figure out, especially since we're going to be remote till I think September 1st is the date we have.
Yeah.
Has everybody in this group been vaccinated twice? Okay.
I just got mine on second one on Saturday. So.
Okay. All right.
Okay, so I guess we'll stay remote for this one at least.
Yeah, I'll get some clarification too, and you know, from our standpoint, you know, selfishly the easiest location for me to use would be National Life in Montpelier, which isn't convenient for everyone, I understand. But even whether they're allowing guests into the building is unclear to me at this point. Any other questions?
So I want to make sure that we do talk about a facilitator at the next meeting.
Yeah, we keep moving that one down.
Yeah, no, for me, I want the agency to be a full participant in the conversation. And I know from having chaired various meetings here and about, it's hard to chair and participate.
Yeah. That's why I just putting that question out to the committee, understanding that chairing and full participation from my behalf will be difficult.
I don't know. Jeff's a fairly young guy and he seems to be doing a pretty good job at it. But if you feel, I don't see a huge need, but on the other hand, Jeff, if you feel that you could better participate if someone else were kind of orchestrating and keeping notes, then it doesn't bother me.
I think the way that we should approach this is, you know, I will keep doing what I'm doing, but if we get to a point where it's just, you know, we'll table it for now and then people will be like, okay, we need now have a moderator things, or, you know, just make things smoother. That would work for me. If that works for the rest of the group.
All right, as long as you're still comfortable at this point, Jeff, that's fine by me.
Okay.
Yeah. I think you're doing a good.
Thanks, Sam.
Yeah.
All right. Thank you all. And I'll send out the meeting invite and get everything going for our next meeting.
Okay, thanks. Take care, everyone.
Yep.
Thank
Thanks.
you. Good to see you all.
Bye.
Thank you. See ya.
Bye.